JMath.
The last part of calculus is always a word sum. So there are a multitude of variations and everything. So I can't possibly show you all of them, but I can show you some groups of questions that normally come up. But unfortunately, this is one of those places in math where it's completely random. You don't know what you're going to get in your paper. Prepare as much as you can, but then just hope you get a good one. So I'm going to do two videos on this. The first one is just going to be random sums where they just give you a story and you just need to know how to put calculus into it to answer their questions. And then the last one I'm going to do is with shapes, volume, surface area, and things like that. And then I'll just do random exam questions that I'll just do one-off questions so you can see all the various types and things, but it's not going to be as extensively explained as in these two videos. So let's start with this one. So the first concept that you really need to know is that they are probably going to give you a formula, and that would be your fx formula. So in these questions, there's sums about height and volume and distance and everything, but it's not connected to a shape. Then that formula is your fx. So the derivative in this case would be the rate of change, as most sums would call it, or if you can see that something is increasing or decreasing and they ask you how much is it increasing at a certain time, then that is always the derivative. Something else you need to know are these key concepts I put in this block below. This isn't all of them, but this is some to just start you off with. So whenever they talk about something initial and it's a sum of that with time, then time would be 0. Okay, the average rate of change is the gradient formula. So y2 minus y1 over x2 minus x1. If they ask you for the rate of change at a specific time, then it is the derivative. So that's the catch in these sums. So please make sure that you know average is always connected to a formula. The rate of change at a specific point is just something I sub into, the derivative. Whenever something increases, the derivative is positive, and then when the derivative is negative, that same thing is decreasing. The minimum or the maximum in these sums are always where the derivative is equal to 0, but watch out, the minimum or maximum rate of change is where the double derivative is equal to 0. Okay, I'm sure you are very confused with what I'm telling you, so let me show you some sums, and hopefully it would make more sense. So this first video sums isn't as complicated, I think, but you can tell me in the comments if I lie to you. Question 1. A windmill supplies water to a dam, which is then used for irrigation. The volume of water in the dam, measured in kiloliters, changes according to the formula, where T is measured in days, okay? So the formula is for volume of the dam, and that is now my original, so fx, as I'm used to doing with calculus. Question A. What is the average, okay, so very important that you see that word, average rate of change in the volume during the second day, okay? So this is logic, but the second day starts at the end of the first day. So I am going to have to get two coordinates, and because time represents days, I'm going to get the end of day 1 and then the end of day 2. And that I'm going to use to find the gradient. So if I sub 1 into the V formula, I am going to get V is equal to 50 plus 6 times 1 minus 1 squared, and that just gives me 56 minus 1 is 55. Okay. Now, with the next one, if I now just sub in 2, then I'm going to get 50 plus 12 is 62, minus 4 is 58. Now I can use the gradient formula to work out what the average rate of change was during the second day. So I'm just going to put that as a M, 58 minus 55 over 2 minus 1, and that just gives me a 3. So the answer for question A is then just 3. But now, very important with these stories, you need to now see, is this kiloliters? Is this something else? So in this case, this is kiloliters per day. Okay, question B, what is the rate of change in the volume after 2 days? Okay, so not the average, so I'm not doing the same as in question A. And that's what makes these two different. So now I can just use the derivative and sub in a 2. So if V was equal to 50 plus 6t minus t squared, then I can put my derivative as V prime is 6 minus 2t. And now to answer question B, I just need to put in a 2 there. So the rate of change in volume is going to be 6 minus 2 times 2, which is just going to be 6 minus 4, which is 2. So I can write my answer as 2 kiloliters per day. Question C, does this imply an increase or a decrease in water? Okay, so the average for the day was 3 kiloliters per day. The rate of change of volume after 2 days was 2 kiloliters per day. So does this mean there's less water or more water? Okay, the answer to this is in understanding what the original formula was. So if I interpret this graph, it's a parabola that starts at 50 on the y-axis, so 50 and 0, because the initial water in the dam was 50, and then it goes up for a little bit as the windmill goes, and then it irrigates the fields, so the water is getting less and less. So if they ask me in question C, does this imply that there's an increase or a decrease in the water? For the first part, there is an increase in the water. Then it reaches a turning point somewhere, and then it goes down. So question C, I would say increase. So it increases because even though the shape is a sad parabola, it is still increasing by 2 kiloliters per day. Then there's a turning point and then it starts to decrease. But at this specific point, it is still increasing. Okay, question D. How much water was in the dam initially? Okay, so sorry, spoiler alert, I said that already, 50 kiloliters, because I get that when I make the time 0. Question E. How many full days would it take for this dam to empty? They are just asking me for the x-intercept. So my one x-intercept would be in the negative. But please, with story sums, time can never go negative. Okay, so I'm just ignoring that x-intercept, and I'm just working out the other one. So with this, I'm just using the original formula, and I'm saying, okay, if y is 0, what is t? So 50 minus 6t minus t squared. I am just going to rewrite that and divide by a minus. So t squared plus 6t minus 50. And now I need to see, I don't think there's factors of 50 that's going to subtract to give me a 6. So I'm just going to use the formula. So the formula t is equal to minus b plus minus the square root of b squared minus 4a and then c, all over 2a. And if I type that in a calculator, it tells me it has an x-intercept when t is 4.68 or when t is minus 10.68. That one is not applicable because time can't go negative, and therefore I can answer the question, how many full days will it take to empty the dam? 4 full days. Okay, so always just watch out. I know it's 4.6 and that's closer to 5 days, but there wasn't enough water for 5 days. So 4 full days. Please be very careful with a question like E. So it all depends on how you interpret the question. If you interpret it as, for how many full days will there be water enough to irrigate all the fields, then the answer is 4. But if they ask you how many days would it take to empty this whole dam, then the answer would be 5. So it depends on the interpretation of the question. In this case, it wasn't stated very clearly. So in an exam, they would sharpen this up so it's not ambiguous and you know exactly what answer they want. Question F. After how many days will the water volume decrease at a rate of 4 kiloliters per day? So because they ask me where the rate is decreasing at 4 kiloliters per day, I actually need to make it a minus 4 because it's decreasing. So minus 4 is equal to 6 minus 2t. Take the 2t to the left and then the 4 to the right, and that would be a 10. So on the 5th day, it is decreasing at a rate of minus 4. Okay, guys, you can see it's not too difficult. As long as you know when to use the original, when to use the derivative, you can answer any of these questions. Let's look at another one. Just to show you the randomness of these questions, first we were the windmill for question 1. Now we with infectious disease. So it depends on how creative your teachers are. They can go anywhere with this section. So question 2, an infectious disease is spreading at an alarming rate. It is represented by the function infection is equal to, and then they give me the whole thing, where t represents the number of months after it was first detected, and I the number of people infected. Okay, question A. Calculate the rate, okay, so derivative, at which the disease is spreading after 3 months. So it's not average or anything. It is just get the derivative, sub in 3 into the derivative. So the derivative would be 15 times 3, so 45t squared plus 30. Now, to answer question A, I can now just sub in 3 in the place of t, and then ask my calculator what the answer would be. So the rate is equal to 45 times 3 squared plus 30. So my calculator tells me that's 435, and now I must figure out what unit am I going to give it to this. It's not meter or meter squared. This is actually infected people per month. So I would say infected per month. I don't think they're going to be too strict on this. They are just going to mark the number, but if you want to be extra, you need to put in the right word. Okay, question B. So now the same question, but for 1 year. So don't let them catch you out. I just use the same formula, and 1 year is 12 months. Don't sub in a 1. Sub in a 12, please. And then you would get the answer. My calculator tells me that's 6510 infected per month. Question C. Is the disease spreading at a constant rate? Explain your answer. No, it's definitely not spreading at a constant rate. So remember, I represented a cubic function. And the rate always represents the derivative. And in this case, the derivative would be a parabola, as we saw in previous videos on this playlist. So that's definitely not constant. So to answer the question, you would say no, it's not a constant rate. It fluctuates depending on the day. The derivative is represented by a parabola. Question 3, so now we're back to water and the volume in a water tank. So I can see they give me a formula there. So volume, depending on time, would be equal to 10t minus t squared. And the interval is just for 0 to 10. So this story only lasts for 10 minutes when time is 0 until time is 10. Question 1, what is the volume after 4 minutes? So I can literally just sub in a 4 into all the places where t is now. So 10 times 4 minus 4 squared, that gives me 40 minus 16, so 24, and this is meters cubed. So let me just write it there, 24 meters cubed. So there was nothing weird about that question, just sub it into the original. Now the time taken for the volume to reach 9 meters cubed. So now I'm taking my formula again, but on the left I'm putting in the 9 and then figuring out what the time should be. So I always want t squared as positive, so I'm just going to move that to the left, and then the other one, t squared minus 10t plus 9 should give me 0, and then I solve this trinomial, and it's luckily a very easy one, so t minus 9, t minus 1 equals 0. Therefore, the minutes would be 9 minutes, or 1 minute would give me 9 meters cubed of water in this tank. Question 3. Determine an expression for the rate of change of volume. Okay, rate of change is just the derivative. So I can put volume prime, depending on time, would be 10 minus 2t. So now any question they ask me, depending on rate, I can just sub in that formula. Question 4. Determine the rate of change of volume when time is 4, time is 5, or time is 6 minutes, and then explain your answer. So I'm just taking the derivative, and I'm just going to do 3 sums where I sub in a 4, a 5, and a 6. So 10 minus 8 gives me 2, 10 minus 10 gives me 0, and then 10 minus 12 gives me minus 2. And now I need to figure out what this is. So this is meters cubed per minute. So meters cubed per minute for all 3 of them. Now they're asking me to explain what this means. So at 4 seconds, the water is increasing at 2 cubic meters per minute. When it reaches 5, the water is not increasing or decreasing. Now, for those of you who are still awake, that represents the turning point of the volume because the derivative is 0. And then at 6, it is now minus 2. So this is also a parabola. So at 4 seconds, it's probably there. At 5 seconds, the dot would be there. And at 6 seconds, it's decreasing again. So it would start to go down. Question 5, what was the time taken to reach a maximum volume? Okay, so we just found it. That's when the derivative would be 0, and that was after 5 minutes in this question. Question 6, what is the maximum volume? Okay, so I now know the time for the maximum, but I do not know the volume, and I can't sub it into the green formula. I need to sub it into my original volume formula, so let's do that. So I'm saying, what was the volume after 5 seconds? So 10 times 5 minus 5 squared. That's luckily a very easy one. So 50 minus 25 would give me 25 meters cubed of water in this tank. So what was the maximum volume? 25 meters cubed. Now, if I were to draw this story, it would look something like this. And the turning point would be at 5 and 25. Okay, and therefore this would be my axis of symmetry. And now I can answer question 7, which asks me, what is the time during which the volume is decreasing? So it started at 0, and then it was increasing until 5 minutes. After that, it was decreasing. So therefore, when is this decreasing? When t is between 5 and 10 minutes. Question 8, the time at which there is no water in the tank. So they're talking about this one and this one. Now, if I look at my original equation, and I know the formula for a parabola is ax squared plus bx plus c. That c value tells me where the story begins. And in this case, there isn't a c value, so it is 0. So that means this tank had 0 water when the story started. Okay, now if 5 is the axis of symmetry, then I move 5 there, and I move 5 there. So to answer the question, what is the time when there's no water in the tank? When the minutes are 0, and when the minutes are 10. Now, I know there's students that does not like drawing a picture and inspection method and everything. Shout out Eugene. So I would now just take that formula and make it equal to 0. So say 0 equals 10t minus t squared. I can then take out a minus t in this, and I would be left with minus 10 plus t. And I just make that equal to 0. So therefore, t would be equal to 0. Or minus 10 plus t would be equal to 0. If I take the t to the other side, it is 10 minutes. So there's your formula to solve this question. Question 9, the time at which the rate of increase is 6 meters cubed per minute. Rate tells me I'm going to use the green formula, and rate of increase says it's positive. So I'm going to say 6 is equal to 10 minus 2t, and then if I solve this, the 10 goes over, that becomes a minus 4 minus 2t, and therefore t would just be equal to 2 minutes. So the answer for question 9 would just be 2 minutes. Now, if I do question 10, I'm going to do exactly the same, But now it's not increasing, it's actually decreasing. So I would have to say it's a -8 in the place of rate. So when is the rate -8? I can now just solve this. So this becomes -18 is minus 2t. And therefore, if I divide by -2, this would just be 9 minutes. And that would be the answer for question 10, 9 minutes. Okay, guys, those were 3 very random questions. There, like I said, there's 100 more random questions. I did one once where someone was driving on the highway and they forgot their tap running at home, and the person needed to decide what is cheaper, to pay the fuel to go home and close the tap, or just to go to their meeting and come back later and then hope their house was not flooded. How random is that? But we'll probably do that in a later video so you can see what I mean. Please try the practice video on this and see if it makes sense.
If this video helped you, please like and subscribe.
JMath.